As we've seen, two shapes are congruent if one of the shapes fits exactly onto the other. If we look at these two stars, they fit exactly onto each other, so they are congruent. If we look at these two half moons, they are not congruent because they don't fit exactly onto one another. There are some rules that guarantee that certain triangles are congruent. We need to know to use the rules and use them to show the two triangles are congruent and sometimes do geometric proofs. This is our first property, side, side, side. So if two triangles have equal side lengths, the two triangles are congruent. Here is triangle ABD and it's isosceles. So that means AB is equal to BD. Show that triangle ABD and triangle BCD are congruent. Firstly, we should notice that AB is equal to BD because ABD is an isosceles triangle. We should also know that AC is the same as BC because C is the midpoint of AD. That's just the way isosceles triangles work. BC is a common side of ABD and BCD. This is probably the most important trick to do with congruent triangles. So we can see that both the triangles share that side BC. And this proves that the triangles are congruent. And we use this sort of triple equal sign with a little curly top for congruence. So triangle ABC is congruent to triangle BCD by side, 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 because we've established that AB is the same as BD. Both of the triangles share side BC, and AC is the same as CD because C is the midpoint, which shows that all three sides of the triangles are the same, so that means by side, 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 the triangles are congruent. Here's a question for you to try. Please pause the video and have a go at the proof. We want to prove that triangle ABC is congruent to triangle ACD. Here is the answer. So firstly, we should notice that BC is the same as AD and AB is the same as CD because ABCD is a parallelogram. Secondly, BD is a common side of triangles ABD and BCD. Therefore, we can say that ABD and BCD are congruent by side, side, side because we've showed they share this side in common. This side is the same as this side is the same as this one up here. So what that does, and I should be using more, I shouldn't be using the line there, but what that shows us is that the two triangles have equal sides, so by side, side, side they are congruent. Our next property is SAS, side, angle, side. So if two triangles share two sides and the included angle, they are congruent. For example, let's prove that ABC and DEF in this example are congruent. What we can say is that angle DEF, so this angle here, we know that's equal to 30 degrees because angles in a triangle add up to 180. But then we know that AB is 10, which is the same as EF, AC is 8, which is the same as ED, so we can see that the triangles have two sides in common as well as the included angle. So we can say ABC is congruent to DEF by SAS. Here's a question for you to try. Please pause the video now and have a go, and when you're ready for the answer, press play. Here's the answer. First of all, AB is equal to BC because B is the midpoint of AC. So we can say that these two sides are equal. And we can also say that these two sides are equal because B is also the midpoint of ED. Then by vertically opposite angles, we should notice that these two angles, so ABD and EBC, are also equal. So that tells us that these two triangles, ABD and EBC, share two sides and the included angle, which means that by SAS they are congruent. Our next property is angle, side, angle. So this time, if two triangles share two angles and the side in between, they are congruent. So two angles, and what we could say really is the included side, the side in between. This makes the two triangles congruent. Here's an example for us to try. So if we want to show that these two triangles are congruent, we could say, well, the triangle on the left, ABC, has got 40 degrees, 12 and 20 degrees. And we can calculate with the for the triangle on the right what the missing angle is. We add up the angles we know, 140, take away from 180, we get 40. So we can see the two triangles have 40 degrees, 12 centimeters in between, and then 20 degrees, which tells us that they're congruent by angle, side, angle. Finally, if two triangles share two angles and the non-included side, they are congruent. So basically, if they share two angles and the included side, or if they share two angles and the non-included side, they are congruent. And realistically, this is really just a consequence of ASA from earlier on, because we know that the missing angle is going to be the same in both. So really it's just equivalent to the other ones, but it's nice to know angle, angle, side is another condition of congruence. And finally, we have RHS. If two right-angled triangles share a hypotenuse and a shorter side, they're automatically congruent. And really, this is just obvious from Pythagoras' theorem. If they share a hypotenuse and a shorter side, Pythagoras forces them to share the other shorter side. This is a typical GCSE question on this topic. So we are given 8 triangles, and using only the information given, we want to state which two triangles are congruent and give the condition of congruency. So we need to give the two congruent triangles and the condition of congruency. If we notice D and E, not D and D, sorry, D and F, we should notice that these two triangles share 53, 98. They have two angles in common and the non-included side. So we can say AAS holds. So this is D and F, and the condition of congruency is angle, angle, side. None of the other ones work. I mean, if we look at B and H, you might be tempted to say that that's right because they have two sides, but they don't have necessarily the included angle. If we look at G and C, we have two sides and a non-included angle, but the problem is the fact that 34 degrees lies on the opposite side to where it lies on G, so that's no good. In fact, that's not even a property actually. Angle side isn't one, so that's not right. And you can see A and E, they share the same angles, which means that they're similar triangles, but not necessarily congruent. Here's a question for you to try. Please pause the video now and have a go, and when you're ready for the answer, press play. So we should have that A and G are congruent by side, angle, side, because they share two sides and the included angle. And then D and E are congruent because of side, side, side. They have the same sides. This is a challenging GCSE question. Pause the video now and have a go, and if you'd like a hint, press the play button, and then we'll go through it that way. The first thing we should notice straight away is that AB is equal to AC, because the triangle ABC is isosceles. We should also know that AP is equal to AQ. That's given to us. And if we look at the triangles that we're actually trying to prove are congruent, it's ABQ. Now we know that AQ is equal to AP, if I just use a different color. So AP as well. So if we look at this, we know that AP is AQ, because they just given us that in the question. And we know that this angle A is in common, so we can say angle BAQ is shared by the two triangles. So that's common to triangle ABQ and triangle ACP. So we can say that they both have, so we can say that they share two sides. So we can say that both triangles share two sides and the included angle. Okay, we just try and draw that a little bit better. So we can see if we look at ABQ, so ABQ, gotcha, BAQ, and then if I look here, we know that they share these two sides, or not these two, we know that they share this side and this side. And because A is in common, or angle BAC is in common, they also share the angle in between. So we can say that they have two sides in the included angle, so they are congruent by SAS. So I can say triangle ABC, ABQ even, is congruent to triangle ACP by SAS.